Let's explore how to visually confirm your build strategy and laser paths, ensuring everything is perfectly aligned for your additive manufacturing process. First, open the Edit Build Strategy dialog to choose your preferred build strategy for the current part. Once set, switch over to the Path Viewer Navigator. This is where the magic happens. Use the Calculate Slice Levels command to generate all the necessary slice levels based on your chosen strategy. With your slices generated, you can now use the Layer slider to easily browse and visualize individual layers directly in the graphics window. This gives you a fantastic detailed look at each cross-section of your part before it's even built. To see the actual laser path, simply click the Generate Path Preview command for any selected layer. Then, use the Steps slider to step through and view the precise order of vector path sequences. This ensures every detail of your build is exactly as intended. This visual confirmation ensures confident and precise additive manufacturing. Let's explore how to manage and visualize mesh scale, giving you precise control over your additive manufacturing parts. In the Additive Manufacturing Navigator, simply right-click any column heading and select Mesh Scale from the configurations. The mesh scale values for each part, if defined, will now be clearly displayed in their respective columns. You have a couple of ways to adjust these values. Use the Mesh Scale command on one or multiple regions to modify the factors as needed. Alternatively, you can directly edit the mesh scale values right there in the columns. For immediate feedback, enable the Preview toggle within the Mesh Scale command to visualize the scaled output mesh directly in your NX graphics window. This powerful visualization ensures your parts are always prepared with the optimal mesh scale. Let us look at how to precisely manage and visualize mesh scale settings, starting from your material profiles all the way to your build tray. First, open your build profile library and select the desired build processor. Then, in the Material Profiles section for your chosen printer, you can easily adjust the mesh scale factors as required for your specific material. Next, switch to the Additive Manufacturing Navigator. In the Build Tray panel, simply right-click any column heading and choose Mesh Scale. The mesh scale values for your selected material will now be clearly displayed in the corresponding columns at the build tray level. For a quick visual check, open the Mesh Scale dialog at the build tray level. This allows you to preview the scaled output mesh directly within the NX graphics window, ensuring everything looks just right. This comprehensive control ensures your parts are always prepared with optimal mesh scale. In this video, we're exploring some powerful features that give you incredible control over your additive manufacturing parts, right from the preparation stage. Let's dive in and discover how to optimize those builds for perfect results. Once you've added and precisely positioned a part with multiple bodies, our system makes it wonderfully easy to define each specific body's type. For instance, you can effortlessly change the first body to a support structure for optimal stability during the build, and designate the last body as a lattice for lightweighting or specific functional properties. This granular control is absolutely vital for optimizing your print's performance and characteristics. Sometimes, parts might come in pre-merged, especially after an initial import. No problem at all. You can easily split combined bodies, just like separating that initial merged section. Conversely, if you have multiple bodies that share the same type, and you want to treat them as a single entity, you can merge them together seamlessly. Now, for the really exciting part, defining your build strategy. You can set specific parameters for each different body type. As you can see here, when working with an EOS printer, we can define unique strategies for supports, lattices, and solid sections. This ensures optimal quality and efficiency for every single part of your design, truly leveraging your machine's full potential. The beauty of this system is its adaptability. Depending on the printer you select, different strategies and grouping options become available. Watch as we switch to an STL printer. Notice how the parameters and grouping choices adjust automatically to match its capabilities. For output, you have flexibility too. You can group all your data together or organize files specifically by type. For example, all supports in one folder, all lattices in another. After generating and downloading the data from the build processor server, all your meticulously prepared files are neatly organized in the output directory, ready for your next steps. And there you have it. With these powerful tools, you can precisely manage multi-body parts, refine geometries, and apply printer-specific build strategies with confidence. Let's quickly explore how to define and verify your build strategy, especially when working with laser assignments for optimal precision. Begin by opening the Edit Build Strategy dialog. Here, you can define your preferred strategy and use the laser assignment option to assign specific lasers to one or multiple regions. Always review the laser assignment column in the configuration table to confirm each region is linked to the correct laser number. With your strategy and laser assignment set, create the build job for your Renishaw system. A crucial final step is to open the MTT output file. This allows you to verify that all your assigned lasers are correctly represented in the Renishaw build data. And there you have it, a streamlined process for precise laser control and confident additive manufacturing.